All right, so like I said, page 697 today. And we're going to talk about circles and circumference. And we're going to define some terms. A circle is considered to be a set of points equal distance from a given point. Called the center. All right, so if we have a circle, it's got to have a center. This center is a point, so we can call it point C. Now, whatever point is used to describe the center of the circle is the point that we use to describe the circle. All right, so the symbol for circle C is just a little circle with a dot in it and the capital letter that corresponds to the center of the circle. Okay, so we would call this circle C. All right, now the circle C has a couple of measurements that are very important. One being the radius. All right, so if we go from the center of the circle to the edge of the circle, we created a segment, and segment BC is the radius. All right, the radius always goes from the center to the edge of the circle. Center to the edge of the circle. There's another segment in a circle. Let's start on the left side of this circle. Let's go through the center, and we're going to stop at the other side of the circle. And I'm going to call that A and D. AD is the diameter. All right, diameter goes from one side of the circle to the other. Key point being that it goes through the center. All right, the diameter goes from one side of the circle to the other side through the center. So from one side to the other through the center. Now the radius. The is always equal to 1/2 times the diameter. The radius is equal to half of the diameter. The diameter is always equal to 2 times the radius. All right, diameter goes all the way across the circle through the center. Radius goes from the center of the circle to the edge of the circle. The radius is half the length of the diameter, and the diameter is always twice the length of the radius. All right, and then one more term we need here is a chord. A chord is a segment with endpoints on the circle. A segment with endpoints on the circle. So if we take a point E right here, and we put it on the circle, and then we take point F and put it on the circle, and we connect them, we've got a segment with endpoints on the circle. That's referred to as a chord. Now, this diameter, AD, it also had endpoints on the circle. But since it went through the center, all right, we call that the diameter. But the diameter is technically also a chord, all right? EF has endpoints on the circle. AD has endpoints on the circle. The difference between the two is that EF doesn't go through the center of the circle, all right? And AD does. So those are the differences between a diameter and a chord and a radius. So if you want to look at example 1, and I'll draw it, and then we're going to identify a couple of pieces here. If P is the center of this circle, then we call it circle P. All right, so in this circle that I just drew, if we had to name the circle, all right, its name, that's circle P. Going to use lowercase r for the radius. The radius of this circle would be MP. The diameter of this circle, going to use a lowercase d. The diameter would be ln. All right, diameter. Endpoints on the circle, but it goes through the center. Radius goes from the center of the circle to the edge of the circle. And then a chord. Two chords now. All right, one chord is Mn, and the other chord in this diagram would be Ln. But Ln also doubles as the diameter. All right, so flip the page, take a look at example 2 on page 698. And we've got this circle here. Circle Q. Diameter TU. And a radius QV. Question is, if QV equals 8, what is the diameter? If QV is 8, Q to V is the radius, isn't it? Goes from the center to the edge of the circle. Well, we said earlier that the diameter was twice as big as the radius. So the diameter is equal to 2 times 8. So our diameter is equal to 16. Any questions till now? How about if TU equals 24? What is the radius? If T to U is 24, well, T to U would represent the diameter, wouldn't it? All right, so we said earlier that the radius is equal to 1/2 times the diameter. And now if the diameter is 24, then 1/2 of 24 is 12. And let's look at if QT equals 9. What is QU equal to? So in this diameter, T to U, from T to U, okay? We've also got two radiuses. Q to T is a radius, and Q to U is also a radius. So if Q to T is 9, all right, new example, if Q to T is 9, it's not 8 anymore. Uh-oh. Then how far is it from Q to U? Anybody want to give that one a try? If Q to T is now 9, it's not 8 anymore. If Q to T is 9, from the middle to the edge of the circle, then how far is it from Q to U? It's the same. Good. 9. How far is it from Q to V? It's 9. All right. The radius is always the same. Once you establish a distance or a length from the center of the circle to the edge of the circle, no matter where you draw it, it's the same. We go from Q to R. It's 9. From the center to the edge, anywhere. All right. QS, that would also be 9. No matter where you draw the radius, once you know what it is, it's the same everywhere in the circle. All right? Any questions? All right, then let's take a look at example 3. Find measures in intersecting circles. Now, sometimes these are hard to draw, but we'll give it a try. So let's take this big circle. Put a center in it. And then we've got the center of this little circle is outside of the big circle. So this is point R. This is point S. And this little circle Yep. Now, if we connect the centers of the two circles, we're going to connect R to S. We've got point C right here. And we've got point D. And we're told the diameter of S equals 30. The diameter of S equals 30. So this is circle S on the right, and its diameter is 30. So look, you got to get sometimes a little creative with your drawing. From C all the way across this circle is 30. Agreed? That's the diameter of circle S. The diameter of circle R is 20. The diameter of R is 20. That means from this point all the way through the center to the other side of the circle over here, this dimension is 20. Okay? ds is 9. All right, so d to s, right in here, this is 9. Find CD. C to D is equal to. Okay, so let's not make this harder than it is. If the diameter of circle S is equal to 30, we were given that, then what is the radius of circle S? It's 15, good. The radius of the big circle is 15. So does everybody see this piece right here? C to S. C to S is 15, right? It's a radius. So if C to S is 15, but D to S is 9, isn't C to D equal to 15 minus 9, which is 6? That whole yellow piece is a radius, and the radius is 15. And if the portion from S to D is 9, then what's left completes the radius. So what's left is the 15 minus 9. Okay? Use the diagram to find RC. R to C. All right, so here's R to C. Now look what we got. We found D to S, it was 9, or we were told it was 9, and we found out that C to D was equal to 6. You with me? We need green, RC. So if the diameter of circle R is 20, what's the radius of circle R? That equals 10. So from R all the way to D is the radius, isn't it? Center to the edge of the circle. If R to D is the radius and it equals 10, then doesn't RC equal 10 minus 6? And that piece would be 4. All right, so you're going to have a couple problems where you're going to be given the diameter. You use the diameter to determine the radius, and then you use segment addition postulate to find the missing piece of a radius based on given information. Any questions? All right, then your practice for today will be on page 701. 5 and 6, 10 through 17, and then over on the next page, 18 through 21. All right, make sure that you're checking your odd answers in the back of the book.